Welcome to math class. We are starting off the Math 9 class this semester with the rational numbers unit. So we're going to be looking at unit 3.1 in the Math Makes Sense 9 textbook. So no point in messing around with it. Let's go ahead and get right into the lesson. We are going to be looking at rational numbers, particularly positive and negative numbers. Now, I've found that most people start freaking out when they hit this point. Oh my goodness, numbers can be negative. Da, da, da. You are all, at least if you live in Canada, you are already familiar with the idea of positive and negative numbers. After all, that's how we determine whether or not we're going to go outside in the winter. So let's say on our imaginary dot here, this little spot right here is 0 degrees Celsius, the point at which water freezes. Now we know if I go 10 degrees up, I know that this is going to be warmer. I know that if I go 10 degrees down, I know this is going to be colder. We can use this same idea of things being more or less than zeros being represented with negative numbers in a lot of other mathematical uses, not just in temperature. So that's kind of what we're going to be exploring in this unit. So if we look at that example right here, the label on the package of frozen cranberries says that it must be stored between -18 and -22. On this very exact, very lazy number line, I would show -18 down here and -22 right there, showing that both of those temperatures are colder than -10, even though their numbers are bigger. Okay, the next example, and these are all pulled right out of the textbooks. You can go ahead and follow along in the textbook if you want. Okay. So this is, I'm going to go ahead and bump this down. This is looking at how do negative numbers work on a number line. So you can see they've got a couple examples here. They have one, I want that. They have 1/4 and 3/4, as well as -1/4 and -3/4. Now what they're trying to show you here is that 3/4 itself doesn't change. That distance does not change. If I take 1 kilometer or 1 degree or 1 anything, and I break it down into 1, 2, 3, 4 parts, or 1, 2, 3, 4 sections. Sorry, my new smartboard seems to be a little bit picky today. Over here, I still have that same one unit of 1 kilometer or 1 degree Celsius or $1 or whatever. Break it into 1, 2, 3, 4 equal parts. So I know that 3 of my 4 equal parts, so taking down to my 3/4, that distance is exactly the same as my negative. This is my negative 3/4. The only difference is on which direction or on which side of 0 are my numbers. Okay. Now right here in this particular example, what is going on? Sorry about that. I got a new smartboard. It seems to be being more than a little bit finicky. So like that, it just keeps switching back and forth. Okay, so this particular example here, they were using fractions. What is going on? This new smartboard's not. It's also cockeyed, so my writing probably isn't exactly looking very straight on your screen right now. Okay, so that particular example shows how we can use a number line with fractions. However, we can take those same numbers and convert them into decimals quite easily. I'm going to try and get this off the screen. Doesn't help. Okay, so 1/4 is the same as 0.25. 3/4 is the same as 0.75. So down here, we can actually use the exact same numbers on the number line. Their distances haven't changed compared to their positions whatsoever. They're just being represented as a fraction or a decimal. That's an important distinction to understand We're going to be using it later in this lesson. Okay, so that's what a number line often looks like, and you'll find that the distances don't matter the distances do matter. The distances are the same regardless of which side of zero you're on, positive or negative, but the bigger the number goes in the negative, that means the further away from zero you're getting. So let's take a look at another example here. So we have to understand that there's in between numbers. All right, so we've got a couple examples here. They want us to write the numbers that are in between 1.25 and 3.26. I'm going to do that with a number line. Okay? I'm going to say that 0 is all the way over here, okay, which would make 1.25 right there, and it would make negative 3.26 all the way over there. So now what I need is some numbers that are in between, so in this great big space here, some numbers that are in between those two. So I know right off the bat, I'm going to say 1, smaller than 1.25, bigger than 0. I'm going to say negative 1, and I'm going to say negative 2. So there we go. 3 numbers that fit in between 1.25 and negative 3.26. My next example, similar idea, but slightly more complicated. This is looking at fractions. So I have negative 0.25 and negative 0.26. So I'm going to make this number line. Now, those numbers are very close together, but if I make a number line, they don't necessarily have to be. I'm going to call this 0.25. And I'm sorry, negative 0.25, and I'm going to call this one negative 0.26. We're going to pretend that those are evenly spaced. So I've just chopped up the space in between those two numbers into 10 sections. I could label them as, let's say this one would be negative 0.251. Negative 0.252, so on and so forth. So looking at this now, I've got to pick 3 numbers that are in between. So I'm going to go with negative 0.251, 0.252, 0.253. Okay, those are my 3 rational numbers that are bigger than 0.25 but smaller than 0.26, or well, depending on your definition of bigger and smaller there. Okay, so that's how we do examples like that. Okay. Now, what about when we have big batches of numbers and we want to convert them into number lines so we can start comparing them? Now, right off the bat, I'm going to notice that I have a whole bunch of different denominators here. So this is kind of a pain in the butt to deal with as far as fractions go. If I want to keep these as fractions, what I'm going to do is convert them all into the same denominator. All right, so they all are over top of the same number, then I can easily rank them back and forth. But what we're going to do is we're going to start using our calculator to convert these to decimals. Okay, so there's a method to doing this. It's very, very simple. You follow the instructions. If I have negative 3 over 8, all I punch in is negative 3 divided by 8, and I'm going to get a decimal number right there. Okay? So if I do that for all of these fractions, I actually get, bump this out of the way here, okay? I actually get those numbers right there. Okay? So what you can see is, even though this is a big batch of confusing fractions with different numbers and all that kind of stuff, if I simply convert them into decimals, I find that I have simple, easy, understandable numbers to work with. And then from there, what I can do is go ahead and punch those onto a number line. Okay? So I'm looking at this now, and I know that I'm going to draw a second number line here so I can, or maybe I'm not. We'll kind of demonstrate. So I know that negative 3 over 8 is negative 0.375. Okay? So it was going in, oops, it's going in between 0 and 1. Okay? I know that negative 10 over 4 wound up being negative 2.5, so it winds up going in between negative 2 and negative 3. Okay. 5 over 9 becomes 0.5, so it winds up going, sorry, losing it again here. It winds up going in between 0 and 1. So what I'm going to do is show you how, if I use this method, I convert all of them into all of them into decimals, then I can go ahead and put them onto my number line. So now I have negative 2.5 over here, which is the same as negative 10 over 4. So my first spot on my number line here is negative 10 over 4. Then I've got negative 1.25, which is negative 1 1/4. Okay. My next one up is negative 0.375. So here I've got a very frustrating smartboard today, apparently. So here I have negative 3 over 8. Okay, the next one's 0.5. Okay, so this is 5 over 9. My 0.7 is going to be very close if my smartboard will finally start to listen to me today. 0.7 is 7 over 10. And our very last one is 2.6, which is our 8 over 3 fraction. So that's how I can take those confusing batches of fractions and make them into a nice, orderly, easy number line. Okay, so that's our basic unit our basic introduction to rational numbers and how we punch things into number lines. So we're going to practice that in math class tomorrow. I will see you in class.